All right. So for our free fall, let's recap what we're talking about, okay? So we're going to be outside, right? Somebody's going to be shooting something, right? And when you think about that, that object is going to kind of go this path, right? It'll go up in the air, and then it'll fall back down, right? A couple of things to keep in mind. We know that gravity is going to accelerate it in a downward motion. Everything I write down, you guys should write down. At negative 9.8 meters per second squared. Okay. Also, what we should keep in mind is that there are two components to this vector. So there's going to be a vector in terms, so I'm going to redraw this. That's the path it's going to travel, but let me show you the vector stuff. So we got to think of this stuff in terms of vectors. So the initial velocity coming out, right? This would be our initial velocity coming out. That could be separated into two components. It's going to have the velocity, the initial velocity, v sub x, and we'll say vxi. And then it's also going to have this vy component. Okay, so if we shoot it at an angle, so what we want to do is we want to figure out where it lands, we're going to use the y stuff. This will tell us the time that it'll be in the air. And then once we know the time, to find the displacement in the x direction, delta x, is simply going to equal vx initial times the time. That's it. Now, I rigged your problem up in a very specific way. We shot it off the tables in class, right? So we have these tables in class. All right, now they're connected to the ground. Drawing the pictures are important, so please draw the pictures because it's going to help you come test time. And we shot our little Nerf guns, right? And our little Nerf guns left the table and landed like this. Okay? So our vector then is really just the x direction, isn't it? It's really just v sub x. So I rigged the problem. I can't remember what class it was. Somebody was shooting the dart gun on an angle, and I was like, guys, you can't do it that way. It has to be parallel to the floor. Because by rigging the problem this way, it'll make it a little easier for you. So what I really need to figure out then is how much time does it take for it to hit the floor? And I'm going to use this and some formulas. So to figure out the time, remember in your, we wrote this formula, we said delta x, but really it's delta y is equal to the velocity. And we're going to have the y velocity. Oh, shoot. I don't want to do it that way. I'll use the initial. Did I say initial or not? I think we did initial. So we'll say Vy initial times time plus 1/2 times the acceleration due to gravity. So I'm just going to put g times time squared. Okay? I'll give you guys a second to write that down. So this is a formula we wrote down the other day, except what we did was we had delta x instead of delta y. All right. So when we got to think about a couple things. So I know what g is. I don't know what the time is. I do know what delta y is. Okay? But remember, I want to find the time. So I've got to take this and algebraically make it look like t equals some stuff. Okay? The instant the dart comes out of this gun, is it moving up or down in any way? That instant in time, what is the velocity in the y direction? It's coming out of the gun like this. It's going, you know. Is it moving up or down the instant it leaves the dart gun? No. So the velocity, v sub y, initial, is equal to 0. Okay? And then you might say, well, what is delta y? Well, if we go back here, delta y is this distance. It's the table height. Okay? But we're gonna let the computer figure all that stuff out. Okay? So let's go back to this. So I have all the information. So I'm going to say delta y is equal to 0 times time plus 1/2 times g times t squared. Well, 0 times t is 0, so then I'm going to have delta y is equal to 1/2 times g times t squared. And I just want to get this t squared by itself. Okay? What's that? Well, no, I divide this by this. Well, the first thing I would do, actually, instead of divide, I'm going to take, watch this, if I take this whole thing and I multiply it by 2, and I multiply this by 2, because whatever you do on one side, you have to do to the other. What's 1/2 of 2? 1. So these cancel, and I'm left with gt squared. And then over here, I've got delta y equals gt. Remember, our goal is to get t by itself. So I'm going to now divide by g on both sides. And I get 2 delta y over g is equal to t squared. But I don't want t squared, I want t. How do you undo a square? Take the square root. Man, you're really good at this. You must have had an amazing Algebra 2 teacher. Oh, that's right. I did teach Algebra 2. That's right. Forgot about that. Man, I'm having a rough hair day. Just run in here and start teaching. All right, so when I do that, my final equation is t is equal to the square root of 2 delta y all over g. Now, g has got a negative value. You can't take the square root of a negative sign. But what we're going to do is, remember, this dart is falling. So technically, our initial position is 0 meters, right? When we talk about our initial y position. And then it falls down 78 meters, or 0.78 meters, right? So our y final position is 0.78. But in reality, isn't it falling down? So what does it mean when we go down? Yeah, so this would be negative 0.78. Okay? All right. I'll give you guys a second to write that down. And then we're going to plug this formula into our spreadsheet. And it'll tell us the time. And then once we know the time, we're going to plug that time in right over here. Right? We're going to plug our time in right over here. Because v sub x is actually our initial velocity that we calculated. That's why we shot the dart up in the air. We wanted to see how fast that thing was coming out. Okay? All right, here we go. Let's fire this bad boy up. So, let's label some things. So we're going to say delta y. Then we're going to say lowercase g And what else do we need for that formula? Oh yeah, the initial. We'll borrow that from the other slide. All right. So delta y is really this value, but it's the negative of it. So I'm just going to say negative 0.78. Now most of you guys should have had the same amount, and this is in meters. But there was a couple different groups that shot it off this benchtop, just so they. And what was that, like 9.94 or something? Okay. So most of you guys should have that. Now for G, this is the acceleration due to gravity. Okay. That's just negative 9.8. And that unit is in meters per second squared. Right? And then we need V sub x. Vx I, and that is just going to be in meters per second. So now the way it works out in this problem, because I rigged it so where the gun would shoot parallel to the floor, we really have 0 V sub y. So what is V sub x? Well, it's just this value from this tab over here that we calculated. Okay? So we could take that value from here. So what I'm going to do is I'm going to say equals. Okay, so you guys are going to have to do this along with me. You're going to click on equals. Okay? Then what you do is you go over here, click on the tab, and then just click this. And what it says is it says find V, because that's what I've typed here. If you have something typed down here differently, it's just the name of the tab, and then it tells you where to pull the information from. So it should be the name of your tab and apostrophes, exclamation point, and then whatever. It should be C8. All right? Then you hit enter, and it automatically pulls that information over here. So now if I want to find the time, am I going too fast? You guys able to keep up? All right. So now the time, we just got to do that formula. So it's equals, how do we do square root again? Anybody remember? It's SQRT, right? Open your parentheses. So now yes. Yeah. So, all right, we'll come back to this one. I'll come back to this one. So here, you're going to type, watch, I'll do it again. Ready? You're going to type equals. Okay? And then you just take your mouse and you go over here to this tab, click on that tab, and you're just going to click on this. And when you click on it, it'll put this information up here. Then you just hit enter. Did that work? Okay. All right. So now back to here. We're going to say equals SQRT, open parentheses. So our formula has a fraction in it, right? So this is how you put fractions into your spreadsheet. You're going to have to open a second set of parentheses. This is going to be the numerator. What is the numerator? Well, let's look. I forgot. So it's 2 delta y. All right, so I'm going to come over here and I'm going to say 2. I'm going to put in the value 2, just type 2. And then I'm going to say times, and then I'm just going to click on delta y. Then I close one set of parentheses. That is the numerator of that fraction. Then I hit the division symbol. I put a second set of parentheses like this. I open up a new set. Then I'm going to click on gravity. Then I'm going to close the parentheses. But then I have to close the parentheses a second time because I got a fraction trapped inside of a square root. Now, if you're missing one of the parentheses, it'll give you a wrong answer. So double check and make sure you've typed it the way that I've typed it. I can zoom in a little bit if it helps. Does everybody have that typed? Not yet? Okay. Can I move on to the next thing, or is there somebody still typing that? All right, when you're done, you just hit enter. And your time should be pretty close to about 0.4. Everybody should be pretty close to what I have. Okay. Is there anybody that has a number way off? So it's not even a half a second. It's about 0.4 seconds. Now, one thing that you can do if you want to, go over here. We don't need that many decimal places. See this symbol up here at the top? It's got a decimal point and a 0 and an arrow pointing to the left. If you click on that, it decreases how many numbers you see on the decimal. So you can round it to 2 decimal places. It doesn't really round it. It does, but it keeps all the numbers and does the calculations, but it just shows you how many decimal places you want. Now, to find the total distance this thing traveled, right, what you're going to do is you're going to put x ds, well, do I want to call it? Yeah, we'll call it displacement. One more formula. So this formula, you're going to hit equals. And remember, it's just this velocity times the time. So it's just the velocity times the time. And if you typed your spreadsheet just like mine, F2 times FG would work. Okay. Then hit enter. Okay. And then the last thing we're going to do is we're going to compare that to our distances here. So then the next thing you would put is you would put average x and then put empirical. Empirical means what actually happened. So this is like theoretical. This is empirical. So again, we're just going to take the average of all the distances that we shot here. So you type out the word average, open parentheses, and then highlight the distances. Okay. Then close your parentheses. Then hit enter. And you don't need to do the formula. And so what you'll find is that your empirical should be, if you measure things accurately. Now, if you're just like, oh, it doesn't matter, I don't care, it's probably like 1.3, whatever. But if you are very precise in your measurements, and you really took your time to make sure that you got the best measurement, those two numbers should be very close to the same. Okay? Those two numbers should be very close to the same. They're not going to be exactly the same, but they should be pretty close. And so if I do this thing where I take this to 1 decimal, you'll see that I'm only off by 1/10 of a meter, which is a lot. It's 10 centimeters when you think about it. That's not too bad. Okay. Now, is everybody caught up with me? Because there's one last thing we need to calculate. Yes. I typed in, you type equals average, and then you just select these, which is column B2, right? All the way down to B11. And then somewhere over here, you're going to type in margin of error. In this formula, we have to type in the, we want to see how far off we are. And it's not really like, it's not a statistical margin of error. This is like a simple margin of error. So this is not based on distributions or anything like that. This is not how you would really do this in science. The real one in science is a little bit harder. But what you would do is you're going to hit equals. Now, our empirical is a little bit higher than our theoretical. And by the way, this is all empirical, right? We're making calculate. I mean, well, this is, the time should be pretty precise, right? Because we're just, but this is, we're measuring this. We could be off, right? So normally what you would do is you're going to take, and let's write this down in our notes. One last thing. When you, a simple margin of error and maybe margin of error isn't the best term for that. You're really just trying to measure like the, how far off you are. You're going to take the empirical measurement minus the theoretical divided by the theoretical. And that'll give you a decimal, okay? And so one other thing is that if your simple margin of error, if this is a negative value, you are under. Because sometimes kids will get confused and they flip flop the numerator. Like sometimes they'll say theoretical minus empirical, and then if you have a positive one, then you're over. Okay. So when I do the math, if I have a negative number, that means the data that I actually observed, that I measured, is slightly, if I have a negative one, it's going to say that I'm under what the theoretical is supposed to be. And then if it's a positive value, it means that I'm over. Okay. And because it'll be a decimal, we can end up with a percentage. All right. Does everybody have this written down? I still see some people writing, so I'll wait. Okay. What about now? So to put that in there, what I'm going to do is I'm going to start, because I got to do a fraction. The numerator is going to be the empirical minus the theoretical, and then I got to close the parentheses. So it's empirical minus x displacement divided by x displacement again. So you just click on that a second time. And so this number is a decimal, and you want to round that to like 2 decimal places. And ideally, you want that number to be less than 5. Is anybody in here that has that less than 0.05? That means you weren't the most accurate in your measurements. It should be less than 0.05. Now, one last thing. See this percentage symbol here? When this is highlighted, just hit the percentage, and it'll tell you the percent. So my margin of error, and this is, you actually, when you do real science, you would calculate you would do this, you do it at least 30 times, calculate each individual calculation, and then the way you would find the margin of error is you would need to know how to do statistics and stuff. But it's not far off from this. You would just kind of repeat this process several times and then kind of standardize it. But ideally, you would like for this to be less than 5%. Okay? And if it's less than 5%, then you know what you're doing is right. Now, if you're not quite less than 5%, it just means that you guys are need to measure a little more precisely. Okay. There was a class where I said they just said, I think it's this. I said, well, what is it really? They weren't using their phone to record where it landed, and I said, I can eyeball it, and I was like, no, record it and see. It matters. I'm curious to see what their percentage will be later today. Okay. All right. Any questions on this stuff? All right. So that is what I have planned for you guys today.